So what we're doing is we're going to talk about ANOVA today. And ANOVA stands for what? You remember what it's abbreviated for?
Analysis of variation.
Yep, analysis of variance or variation. So what we're doing is we're analyzing how things vary from one another. What we're essentially doing is we're going to have two things. Your question responds with how does this differ from this? Well, treatment C, the numbers are different, but we're actually going to talk about what that actually does. When we calculate an analysis of variance, I did it on StatCrunch here for us, but then I'll actually show you where these numbers come from. So what you're doing with analysis of variance, we have degrees of freedom. Degrees of freedom between and within. What we're doing is how many different groups do we have?
3.
3. So the degrees of freedom here is going to be 3 minus 1. We're going to subtract 1. What we're doing is we're comparing treatment A, treatment B, and treatment C. So that's what we're doing with the between. Now the within, what we have to do is we have to look at how much data we have. How much data do we have, or how many data points do we have?
15.
We have 15, but we have 3 groups. So we actually subtract 3 out of them. So if you notice, that's how we get the 2 and the 14, sorry, the 2 and the 12, but then 2 and 12 gives us 14 in total for that. So that's how those come. So what we're doing is we're comparing all the data with itself and the data between the groups. That's what analysis of variance means. SS means sum of the squares. So what you want to do is we're essentially going to calculate something called the mean squares. So we want to calculate a mean. In order to do that, we have to add them all up, divide by how many they have. But we're not going to do the mean, we're going to do what's called mean squares. So what happens is if you do the sum of squares here, this would just give me 70, and this gives me 34. Now, one thing that I've talked with my colleagues just say you need to know how to want it. You don't need to know the details of where to get the numbers. To do this by hand is a little tricky. That's why we have you use technology. Either StatCrunch or Graphing Calculator will let you use it. So that's what we call sum of squares, and it actually gets a little bit more work. Part of the reason is we don't want you spending like 30 minutes on just one problem. So we kind of just let you use technology to speed it up. But what we have is we have a formula to find what we call sum of squares. So now to do the mean squares, what we actually do is we do 70 divided by 2. Where did that 2 come from? What's my
degree of freedom?
Mm-hmm.
Okay.
Okay, so then this would be 34 divided by what number?
12.
12. So if you do 70 divided by 2, notice that we do get that 35. And then do the 34 over 12, notice you do get that 2.833. Now the F-stat is also referred to as the F ratio. Why is that? Because we take the mean squares between divided by the mean squares within. So what we have to do is we're essentially comparing the groups to each other and all of them at once. So we are looking at the variance between the different groups and the variance of all the data to make sure it doesn't change too much. That's what the F-stat is, and that's what the ratio is. Now, what we want is we want to go back to your question of how does this scenario differ from the scenario, how does the scenario on the left differ from the scenario on the right? Well, treatment A, what happens?
Same.
It's the same. How about treatment B?
Stay the same.
Same. How about treatment C?
It looks like decreased.
It looks like, yeah, the smaller. Not only that, is treatment C, doesn't it look closer to treatment B?
Yeah.
Well, that's the thing I want to know. You know, if you compare like these are like closer together.
Mm-hmm.
The data and the groups are closer together. What does that mean? That means this between going to be a lot smaller. And if that between's a lot smaller, what's going to happen to my F ratio? Is it going to be bigger or smaller?
Smaller.
The F ratio is going to be smaller.
Mhm.
I see. What we're doing visually is we're doing this. Let's say this is going to be case 1. This is case 2. What happens visually is in case 1, what are we doing? Well, we're analyzing, this might be treatment A, this is treatment B, this is treatment C, this is A, B, C. While in case 2, visually what happens? This is A, this is still B, but then what happens? This is C. C's closer in line to both of them. And I'm sorry,
It's okay.
move it. But that's what's going on. In case 1, C diverges from A and B a lot. In case 2, C's closer to A and B. Visually, if you graph it. So you could kind of see that just like looking at these numbers. Hey, in case 2, treatment C's more in line with A.
Yeah. Okay.
Visually, that's how you represent it. You look at the distributions and they should be close to each other.
Okay. Thank
You
you.
could also look at, let's say, a 5-box summary, and you could get something like this. Like, let's say this is 1, this is 2,
Screen.
that's 3. Okay, sorry. Versus a case 2. Thank you for the reminder. Well, this might be the 5-number summary. This might be the 5-number summary. This might be the 5-number summary. This has a large F stat, and this will have a smaller, and I should say larger stat, F stat. Why? Because all the data within the groups are closer together. So that's essentially what we're doing visually. How close are the entire distributions to each other? Are they really close together like this, or are they really far apart like that? So visually, you understand that. What
So,
oh, I'm sorry, go ahead.
so larger F stat means also means larger F ratio.
Yeah,
Okay.
F stat is the F ratio.
Oh, okay. Okay.
So F stat is the same as the F ratio. So we remember we were talking about test statistics. The F ratio is our statistic.
Mm-hmm.
So you have, you know, the said, said stat, T stat, chi-square stat, and then the F stat.
Mm-hmm.
But the F stat's just the ratio. But that's essentially what you're trying to do, calculate numerically. Visually, we understand, hey, this data, these groups of data, how close do the groups agree with each other? Are they really close or are they far apart? We try to create a numerical number to that. That numerical number is the F ratio F stat. So
Okay.
that the more the groups tend to diverge from each other.
Okay.
That's why when we do ANOVA, this is multiple samples because we're comparing multiple things all the time.
Yeah. Okay. Thank you. Thank you.